here is because there are other people out there that are claiming that gases are not affected by a downward acceleration. While it is true that gas molecules, when you equalize from one tank to another, and you initially get that rush of gas molecules from a stored container into a vacuum, they will continue to bounce around and bounce and bounce and bounce all over the place. Eventually,
So Bob's bought into the bouncy ball theory of gas molecules. Now, it's already been demonstrated that you take the pressure adjacent to a vacuum tank, basically, and you remove the barrier, then it equalizes instantly. The bromine gas rushes in to the pressureless tank, and the only thing that changes is entropy. There's no energy transfer. There's no temperature, no nothing. Okay, but according to Bob, I guess they just keep bouncing and bouncing, and eventually there is a change in energy. Okay, not initially when everything rushes in, but eventually it does change. Come on, man.
even sometimes in the same place, right?
So Bob, does that, at the risk of sounding stupid, and I'm feeling pretty stupid at the moment, but does when you say everything goes down, do you mean gases as well inside this device?
Even gases will, yes, because if you have helium, and helium is the least dense gas we know, right?
Mm-hmm.
But even helium has to be, if it's going to rise, it has to float up on something, right? Well, if there's nothing to float up on, then what's it going to do? It's going to sit on the bottom.
So helium is going to sit on the bottom. Is that what I'm hearing? Helium is going to collect at the bottom of a vacuum chamber. Oh my God. Are you kidding me? Another parlor trick. Okay, allow me to demonstrate.
Okay, helium balloons in a vacuum chamber. 3, 2, 1. Trying to turn it off right before they pop. Oh, that one fell. See? Stop floating.
There we go, yeah. I was completely wrong. The helium does go down in a vacuum chamber. Or does it? Okay, the helium's lifting capacity has appeared to go down. But look at the helium. It is blowing every direction. The balloon is not sagging toward the bottom. I repeat, the helium is not sagging at the bottom. It will never go down to the bottom of a vacuum chamber. That is fucking retarded. The helium will blow in every direction. That balloon will expand. It's not pooling at the bottom. I understand they think that in their brains, but look at the balloon. The balloon is expanding in every direction. Just because the balloon went down, the helium did not. It is expanding more and more in every direction. So what this guy is doing, I've showed this before, but apparently it's not sinking in. This guy's putting balloons in liquid nitrogen, cooling them down, and they completely deflate. As soon as they warm back up, when he pulls them out, they inflate. And this has nothing to, let's say, I've raised this point because high in our atmosphere, okay, as high as we could see, it gets colder and colder. And in my opinion, the air is still there, okay? There's no void. It may, you could maybe consider it a vacuum by some sense of the word, but not a void. It has nothing to do with gravity. If we don't have a void anywhere, then all we need is relative density disequilibrium. That would explain everything. If you hit a void somewhere, if you start thinking like outside of our realm, then you would need some sort of force to explain vectors, but everything follows the rules of relative density. Everything. There's no getting around it. And as long as there's a medium and all the way up to the firmament, whatever it may be, it's then all matter will behave accordingly. So let's see. He's got that last balloon he put in there is a pretty big one. But they inflate pretty quickly once he pulls them out. So the higher and higher you go up in the atmosphere, the colder it gets. Okay, they tell us that there's a thermosphere with 4,000 degree plus temperatures, but we just can't feel the heat or because the molecules. I call bullshit on that until they can prove that. For what I see, it keeps getting colder and colder, and I don't think we have a complete understanding of what happens to stuff at super cold temperatures. You know, once you start getting down in extreme low temperatures. But the material, the matter, the air, the gases, they are still there. They're just cold, deflated, like these balloons.
For illustration purposes, show you what goes on with the air here. So basically we have two, quote, normal or room temperature vases of air here.
Right, the atmosphere, okay.
It's the atmosphere,
All right.
but we also have in two cups here, red dyed air, and we also have blue dyed air. One represents warm air, one represents cold air. So what we're going to do, Tom, is we're going to take some of the warm air first. We're going to put it in our syringe here, and we're going to put it in.
I'll step back for this part.
Put your
And we'll
board
get
up
this
there.
up
We'll put
here.
it in, and
Ready?
watch what happens here, right? And explain to our viewers what's going on here, Tom.
Well, you see the air mix in here, and this is, the warmer air is less dense, and that less dense air is staying where? At the top half of the cylinder, or the top half of this portion of the atmosphere.
Now, if we take our cold air that we have, and this is ice cold water, and we plunge this in, Tom, it should indeed be heavier and go down, more dense, and go down to the bottom, or at least mix down to the bottom, whereas the red didn't.
And it is, indeed, it's going to take some time here, but that cold air mixes down. This is an example of that Arctic front, that Arctic air that worked its way down through the plains.
The point of this is even air, the weight of it is relative to the air that is around it. Everything is relative to what is around. Everything works on equilibrium, and you can claim or call BS on that, but proving it would be impossible because everything happens relative to everything else. And same thing with weight. Okay, if I weigh myself on the scales and I weigh 200 pounds, and then I weigh myself in water and I weigh 20 pounds, or if I weigh myself even in hot water or cold water or more dense water, saline water, the weight is going to be affected. Okay, and there's no downward bias. Okay, it's all relative. Like in the video I showed earlier, the helium doesn't drop. Maybe its ability to support the balloon drops because the vacuum that they create is less dense than the helium. So the helium is just still following the same rules, but the helium is still blowing in every direction. The balloon is inflated. There's no extra pressure at the bottom of the balloon. That is ridiculous. And if you take, like in high school or middle school, they had us take a balloon, weigh it on a scales, on a sensitive scale, and then blow it up with air and weigh it. Okay, and to show that air has weight. But you know, in hindsight, looking back at that, if we took a balloon and filled it up with air, depends on the temperature of the air and the temperature that the balloon is in. For example, if you put hot air in the balloon, hotter than the air around it, the balloon would have lost weight on the scales. Okay, if you take cold air, it would gain. It all depends. You can change the And the same thing with pressure. You can change what's around it. Okay, if you have a balloon with pressure and you put it in a cold environment, it's going to change, the balloon's going to change pressure. It's going to change weight. It's everything happens in harmony and in equilibrium. So you can look back at that experiment where we put the balloon on the scale and just imagine if we had put hot air in there, it maybe even floated off, depending on the temperature of the air and depending on the temperature of the room that you did it in. I think we all know this, but it's not sinking in. Okay? There's no downward bias. Cannot be proven. And maybe there is a force of the electrostatics. I mean, maybe that does have something to do with the weight of things. Maybe it plays a small role, but everything still is just acting in accordance of relative density. I don't think there's no way to disprove that. Listen up, everybody. I should not have to keep demonstrating this or explaining it. It's freaking simple. The balloon going up or down, it depends on everything around it and everything inside of it. If you try and tell me this air has weight and that there are little bouncy balls of molecules of air inside this, I'm going to call bullshit. Okay? The air does not have weight. If I heat the air up in this balloon, it will go up. If I cool it down, it will go down. Okay? If I put helium in this balloon and I put it in a vacuum chamber, it will not support the weight of the shell of the balloon because the vacuum is less dense than the helium. But the balloon will still blow every direction. There will be no extra pressure on the bottom of this balloon. Okay? Likewise, if I pull this balloon underwater, okay, then it's in a denser medium and it is going to come up faster. But the balloon is going to still blow. The helium in there is going to be going in every direction, whether it's going up or down. The helium will be going in every direction. It does not have weight outside of what is around it in the medium that it is in. Come on, this is not that hard to understand, people. There is no need for a force unless you have a void. As long as there's a medium, everything's going to act in accordance of itself and its properties and the medium around it. When you start talking about voids in Never Never Land, which I've never seen proof of, then you start needing forces, okay? Until I get proof of that, I don't need a force. Relative density explains it all. There's no buoyancy needed, okay? We can assign math to solids falling in air. You know, none of that has to change, okay? But what's really going on is obvious, okay? Everything acts in harmony and equilibrium. To me, there's no way to disprove that. That is my opinion. Thank you very much.